Hello everyone, this is me, Bikram Yadav, bearing the USA number 1B in 19CB004 and currently pursuing the Bachelor of Engineering from Sri Venkateswara College of Engineering, Bengaluru. Today I am going to present the seminar topic on the seismic behavior of soil nailed wall under the guidance of Mrs. Lavanya S. Now let's move to the content parts and it goes like this. First one is introduction, second one is origins, third one is applications, fourth one is methodology, fifth one is design approaches, sixth one is masonry used for soil nailing, seventh one is material used for soil nailing, eighth one is advantage and disadvantage, ninth one is conclusion, and last one is references. Now, introduction part. Soil nailing is a technique used to reinforce and strengthen existing ground. Soil nailing consists of instantly closely spaced bar into a slope or excavation as construction proceeds from top down. It is an effective and economical method of construction retaining wall for excavation supports of hill courts, bridge abutment, and highway. This process is effective in cohesive soil, broken rocks, shales, or fixed face conditions. Now, origins. Soil nailing evolved from the new Estelian tunneling method, which is a system for undergrounded excavation in rock. This concept of combining passive steel, reinforced cement, and shotcrete has also been applied to the stabilization of rock slope since the early 1960s. The first application of soil nailing was implemented in 1972 for a railroad winding project near a Kansas. The technique included installing high-density grouted soil nails into a 60 feet high wall and facing it with reinforced concrete. The United States first used soil nailing in 1976 for the support of 13.7-meter deep foundation excavation in dense silty sands. Now, applications. Stabilizations of railroads and highway cut slopes. Excavation retaining structure in urban area for high-rise building and underground facilities. Tunnel porters in steep and unstable stratified slope. Construction and reform fittings of bridge abutment with complex boundaries involving wall supported under pile foundations. Stabilizing steep cutting to maximize development space. The stabilizing of existing over steep embankment. Soil nailing through existing concrete or masonry structures such as falling retaining wall and bridge abutment to provide a long-term stability without demolishing and rebuilding cost. Temporary support can be provided to excavations without the need for bulky and intrusive scaffold type temporary work solution. Now, methodology. Driven nail, grouted nails, jet grouted nails, launched nails. Now let's move to the driven nails. Generally, small diameter nails 15 to 46 mm with a relatively limited length to about 20 meters made of mild steels about 50 km that are closely spaced in the wall 2 or 4 nail per square meter. Nails with an axial channel can be used to permit the additions of grouted shelling. Driven nails are the quickest and most economical to install. Grouted nails, steel bar with diameters ranging from 15 to 46 mm, stronger than driven nails, about 60 km. Grouted nails are inserted into a bore holes of 10 to 15 centimeter and then cement grounded. Ribbed bar are also used to increase soil adhesion. Corrosion protected nails for aggressive soil as well as for permanent structures. Jet grouted nails, a composite of grouted soil and a central steel rod up to 40 centimeter thick. Nails are installed using a high frequency vibers, precautions, hammer, and cement grouted is injected during installation. This method has been shown to increase the pull-out resistance of the composite and the nail are corrosion resistance. Launch drill. Nails between 25 and 38 mm in diameters and up to 6 meter or longer are fired directly into the soil with a compressed air launchers. Used primarily for slope stabilization. This technique involves the least site disturbance. These are the diagram of typical soil wall arrangement that can be detailed showing the nailing into the soil. Now, design approaches. The two most common design approaches for soil nail wall are limited state design and service load design. Initial design concentration included wall layout, wall height and length, soil nail vertical and horizontal spacing, soil nail pattern on wall face, soil nail inclination, soil nail length and distribution, soil nail material and relevant ground properties. The next step is to use simplified chart to preliminary evaluated nail length and maximum nail force. Nail length, diameter and spacing typical control external and internal stability of the wall. These parameters can be adjusted during design until all external and internal stability requirements are met. After the initial design is completed, final design progress where the soil nail wall has to be tested for external and internal failure mode, seismic concentrations and aesthetic qualities. Drainage, forced penetration and external load such as wind and hydrostatics force also have to determine and included in the final examination of the design. Now, machinery is used for soil kneading, drilling equipments, grouted mixing equipments, salt creating, grinding equipments, compressors, drilling equipments, rotatory air thrust and water thrust, down the hole hammer, tricone bit. It is must to procure drilling equipment with sufficient power and rigid drill rods. Grout mix equipments. In order to proceed uniform grouted mix, high speed shear colloidal mixer should be considered. Powerful grout pump is essential for uninterrupted delivery for grout mix. If fine aggregate is used as filler for economy, especially grouted pump shall be used. Short creating graniting equipments. Dry mix method will require a valve at the nozzle outlet to control the amount of water injecting into the high pressurized flow of sand or cement mix. For controlling the thickness of shotcrete, measuring pin shall be injected at a fixed vertical and horizontal intervals to guide the nozzle man. Now, last one is compressor. The compressor shall have minimum capacity to deliver shotcrete at the minimum rate of 9 meter cube per minute. Sometimes the noise of compressor can be an issue if the work is at close proximity to residential area, hospital and school. Steel reinforcement. For corrosion protection, all steel components shall be galvanized. If machine threading after galvanization is unavoidable, then proper zinc-based coating shall be applied onto the thread. For double corrosion protection, the PVC congregated pipe use be for a good quality and adequate thickness. Preferably galvanized congregated steel pipe shall be used. Grout mix. For conventional soil nails, the water cement ratio of the grout mix ranges from 0.4 to 0.5. As most cementous grout will experience some grouted shrinkage, non-shrink additive can be used to reduce bleeding and grouted shrinkage. The resistance at grouted soil interface of nail will significantly reduced when the grouted shrinkage. Now, last one is shotcrete or granite. Shotcrete or granite can be continuous flow of mortar or concrete mix projected at high speed perpendicularly onto the exposed ground surface by means of pneumatic air blowing for dry mix or spraying for wet mix. Now, let's move to advantage. With the right soil and site condition, a rapid and economical means of construction earth retention supported system and retaining walls creates less noise and traffic obstruction, less impacts on nearby properties, allow in seats strengthening or existing slope surface with minimum excavation and backfilling perpendicularly, very suitable for uphill winding, thus environmental friendly. Allow excellence working space in front of excavation phase. Can be used for strengthening, or either natural slope, natural or man-made cut slopes. Grouting only once is required, saving time and labor. The technique is flexible, easy modified. Now, disadvantage. Nail encroachment to retained ground, rendering unusable underground space. Generally, large lateral soil strain during removal of lateral support and ground surface cracking may appear. Tendency of high ground loss due to drilling technique, particularly at coarse-grained soil. Less suitable for coarse-grained soil and soft clay soil, which have short self-supported time and soil prone to creeping. Suitable only for excavation above groundwater. Now, finally, we have the conclusion part. Now, let's go to soil nailing is an accepted technology and theoretical accepted for which are well understood and well reported in technical literature. However, research indicated that are a few particular guidelines available that offer a comprehensive experiences-based insight into the construction consideration that should be addressed before a soil nail system design is finalized and implemented. Now, last but not the least, we have references, and it goes like this. Siva Kumar Babu, GL, ETAL 2002, Analysis of Construction, Factor Influencing the Behavior of Soil Nailed Earth Retaining Walls. Morganian 2002, The Influences of Variations in Effective Stress on the Serviceability of Soil Nail Slope. Lee J. ETAL in 2008, Losses Fill Slope Stabilization with Soil Nail. Thank you.